All of you, welcome back to yet another project video. In this project, you're going to build your own ICO marketplace where you will allow others to create their token, list their token for sale. So this is what exactly we're going to build. Every single thing is controlled by smart contract. So let me give you a quick walkthrough that what are the feature and functionality we have included in our dApp. So this is a simple interface we have. On the first section, we have our header section. We have this menu. So if you click on this ICO marketplace, it's going to give you this pop-up, and here you will find all the tokens which are listed for sale. You can able to see the name, supply. So currently token A has 185 token supply. If you go with the token C, it has 100 token supply, but currently there is no supply for token A. So user can come and they can pass their token into the smart contract of ICO, and it will be reflect here and user can purchase. You can able to see the address, creator, and how much money you have to pay for buying each one of this token. So here you will find all the token listed in ICO marketplace. Close this one. Then we have this created ICO, and here you will find all the ICO which you will create. These are the 3 ICO which I have created with this particular account which I'm connected at the moment, so I can able to see every single thing, and this data is coming from the smart contract. So this is the created ICO section. If I come back to the history, here I will find all the token I'm going to create using this particular smart contract. So currently I have used this contract to create this particular token. You can see the logo, you can see the name, you can see the symbol, supply, address, and transaction hash, which you can copy and you can verify the transaction on the test network. Let's close this one, and here we have the option for create tokens. You can literally create your token to any network. So you have to upload your image, click on that, and you have to pick an image. So I'm going to pick this one, select, and it's going to upload the image to the IPFS. So just wait. Here our image got uploaded successfully. I have to give the name of my token. So I'll say Daulat Hussain. Symbol is going to be DH, and I want to have supply close to 4,000. This much supply I want to have to my token. All you have to do is to simply click on this create token, and it's going to make a call to our smart contract and it's going to deploy. So we have to confirm the transaction. So click on confirm, and here the transaction is processing, and finally the transaction got completed. So if I open my MetaMask, you can see we have a successful transaction. If I click here, I can easily able to confirm the transaction on Etherscan, and I can able to find all the details about our token we have created just now. If I come back to the history, here I will find the token which I have created just now. You can see the logo, name, symbol, supply. I can copy the address, I can copy the transaction hash. And now we are ready to create our ICO. So we can come back here, click on this create ICO. It's going to open this pop-up model. Here you have to provide the token address which you want to list. Then you have to set the price of your token. So I'll go with very less because I don't have much fund in my wallet. So I'll click on this create pre-sale. It's going to make a call to our smart contract, and we have to simply confirm the transaction. So click on confirm, and it's going to create and make the transaction. So once the transaction will complete, you will find that this particular token will be listed for an ICO. So just wait, soon the transaction will complete. And finally the transaction is completed, and you will find the token is listed for an ICO. Currently there is no token available for sale, so we have to transfer the token to our ICO contract. It's time to transfer the token to our ICO contract. So I'm going to transfer the token A because I don't have the balance in my token first account. So I'm going to use the second account, and second account I have used for creating the token A. So let's come back here, simply copy this one, and that's what I'm going to keep it here. Paste the address. Now I'm going to simply copy the address of our ICO contract. Simply click here, copy, and now we're going to use this particular function called transfer token. So click here. We have to pass the address where we want to transfer the token. So I'm going to give the ICO contract address. This is the one. Now I'm going to take the address of our token, copy this, and that's what we have to paste here. And here I have to pass the amount. So I'm going to pass 10 token because I don't have much fund in my wallet. So let's click on this transfer token transfer, and it's going to make a call to our smart contract, and here we are transferring 10 token. Click on this confirm and just wait. Once the transaction will complete, the token will be transferred to our ICO contract, and now user will start buying the token. So this process might take a little bit time, so just wait. And finally the transaction is completed, and we have successfully transferred the token to our ICO contract. So if I come back here, you can see token A has 10 token. So we have successfully transferred the token to our ICO contract. Now if anybody wants to buy the token, they can simply click on this buy, and here they have to paste the quantity they want to take. So I'll go with 1 because I don't have much fund. Click on buy token, and it's going to make a call to our contract, and we have to simply confirm the transaction, and this much money we are paying, and this money will be transferred straight away to the creator wallet. So simply click on confirm, and here the transaction is in the pending state. So just wait, it will take a little bit time to complete the transaction, and finally the transaction is completed and we have bought 1 token. Now it's went down to 9. So this is how anybody can come and they can buy the token. If I want to buy this token, I can click here and I can pay 5, click on buy, this much money I'm going to pay. It's going to make a call to my smart contract, this much fund I'm paying, confirm the transaction, and once the transaction will complete, the token will be transferred to your wallet address, and this much fund you will pay to the creator of the ICO. And we have successfully bought the token and it's went down to 80. Earlier it was 85. So this is how anybody can buy the token. Now let's try to withdraw the token which we have listed in our ICO contract. So if I want to withdraw the token A, all I have to do is to simply get the address of the token, and I'm the one who created this particular ICO, so I can withdraw only, not anybody else. So we have the function for that. So we can come back here in the withdraw token, we can click here, we have to paste the address of the token which we want to withdraw. So I'll paste here, and the quantity, so I'll go with 50 and click on withdraw, and it's going to make a call to our smart contract, and we are withdrawing, calling the withdraw function. We have to confirm the transaction, and once the transaction will complete, we'll successfully withdraw the token from the ICO contract, and it will come back to our wallet address, means the creator address. Just wait, the transaction is in the pending state, and soon the transaction will complete and we'll have our token back. So we have successfully withdrawn the token from our ICO contract and it went to 130. So this is how you can withdraw the token from the ICO contract. So anybody can come, they can create the ICO, they can create their token, they can buy the token, they can withdraw the token. So that's all feature we're going to build. I hope you guys have liked this particular project. We have seen this token transfer, we have seen this withdrawal, we have seen token creator, we have seen the history. That's all we have seen. We have also seen your created ICO. So all the ICO you will create, that's all going to reflect here. We have already seen this ICO marketplace. So if you click here, you can able to see all the ICO which user will create in the marketplace. Here you will find the ICO address. Here you will find the created ICO. So from here you can able to create the ICO. Everything is good. If you check the responsiveness, this is how it's going to look. If you see in the small screen, you can click here and we have this nice drop down. We have the button. You can simply close it. If you look on the small screen, this is how it's going to look. We have this nice slider and where a user can click and they can buy the token. Everything is looking good. So this is what exactly we're going to build in the project. So let's start building. Now we can start working on our project. So first we have to create a folder. Let's call it ICO Marketplace. And this is the folder you have to open in your VS Code. So let me click on VS, click on open, go to desktop, and this is what I have. So simply select and open. So right now we don't have anything in here, so I have already provided you the starter file. So let's download that. So come back to the browser and come back to the blockchain coder. Here you will find all the project we have built on our channel. So that's all you will find here and all the resources. So come back here, go to the resource section from here, or you can simply go back from the bottom as well. So here you will find source code section, and here you will find all the project we have built on our channel. So I would encourage you to build at least 5 of them. So check all the project we have: NFT marketplace, chat application, decentralized voting tab, supply chain, crowdfunding. There is tons of project we have. So make sure to come and check all of it. Now we have to get the starter file. So I'll click here, go to recent project, and this is what we have, in which you will find all the resources. So simply click on this get now, and you will come back here. You will get the final source code or you will get the starter file. So click on the starter file, and from here you can able to download the starter file, in which I have provided all the starter files and everything is mentioned. So simply copy the URL, or you can simply get it from here as a zip file, or you can copy the URL. Simply copy it, and that's what we have to open in our VS Code. So make sure you have to be in the same directory, ICO Marketplace. Now I'm going to make it on the full screen. I'm going to do a little bit zoom, and let's open up our terminal, and we have to type this command git git clone, paste the URL, and you have to give this dot. This dot mean that we want to clone the repository in this particular folder. We don't want to create a separate folder. So simply hit enter, and it's going to clone the entire repository. So we got this entire folder and file structure which I have designed for this entire project. So I'm going to simply close this one, and now let me give you a quick walkthrough that what exactly we have here in this particular folder. So first thing, I'm going to simply delete this one, this git file, and here we have the entire folder and file structure which I have designed. So first thing, we have the component We have the CSV, in that we have the icon. So this icon is already provided to all of you guys. And here we have all the component which we have to build. So we have the button component, buy token, card, create ICO, footer, header, ICO market, input, load, marketplace, pre-sale, table, token creator, token history, token transfer, upload logo, withdraw token. So that's all we have here. These are the component we have. Now we can come back to the context, and that you will find this is the context where we're going to manage the estate, and we're going to import all the important addresses of our project. Here I have given the ABI. So this is the general ABI of ERC20 token, which we're going to utilize for creating token. Here we have the ICO Marketplace ABI. So the contract we're going to create, that's the ABI we're going to provide here. So you can simply remove it, because we're going to deploy our contract through Remix ID and we'll generate an ABI, and that's what we're going to provide it. So that's the ABI, and here we're going to build our entire context management. So it's completely empty, but we have to write a lot of code here. So this is our context. Now we can come back to, we have our contract folder, and that we have to write two contract, ERC20 token and ICO sell contract. Then we have the pages. Inside that we have this tool. It's going to be a single page application. So this is our setup, and here we have this home page which we're going to attach all the component. Then we can come back to public, and this is the logo which I have provided. You can put your logo. If I come back to the style folder inside the global CSS, this is the entire CSS code I have written. So you don't need to do anything. I would suggest you to first complete the project. After that, you can easily able to do modification based on the branding. So that's all is here. You can easily able to do the modify. Now I'm going to simply close here, and here I'm going to keep all the important environment variables. So you have to paste your address of your contract, and you have to get your own Pinata API key and secret key, which I will tell you how you can get it. So we're going to update this together. So just wait. So this is our .env file, and these going to be the same. You don't need to do any changes. Now come back to the packages and file, and here you will find all the packages we are utilizing in our project. So this is the name I have given. This is the script, and we are using all of these packages. So you don't need to make any changes. Make sure to let it be like this, because all the customization, all the setups I have done as per this particular packages. Some of the packages or maybe get updated in the future, but as long as you will work with the same packages, it will work absolutely fine, no matter after how many years you are building this project. 5 years or 10 years, it will work absolutely fine. So this is our packages and file. Now I'm going to simply close it up, and now we have to open our terminal, and we have to check couple of requirements. So if I open up my terminal, you will see that I'm using this particular node version. I am using the latest one. So simply type node node-v. I'm using the latest node version. It will work absolutely fine with the old version. If it's create any problem, make sure to upgrade it. If I check the npm version, I'm using this one. You can go with the old one, or you can go with the latest one. It will work absolutely fine. But if it's create any problem, then make sure to upgrade your node version or npm version to this, which I have explained in this video. So that's the first thing. Now I'm going to simply clear it up, and I have to install the packages. So to install, I can type npm I, or I can type install. Both will work fine. So hit enter, and it's going to install all the packages we have defined here in our node module. So everything is looking absolutely fine. We have successfully installed our package. Now if I simply clear up my terminal and start the application, simply type npm run dev, and this one is going to start the application on localhost 3000. You can simply ignore this message. I'm getting this message because I have the latest node version in my system. But if you have the old one, it will work absolutely fine, because some of the packages have the update, but we want to go with the old configuration, which is the most stable one at the moment. So it's working absolutely fine. Now you can come back to the browser. I can go back here, click on this localhost 3000, or you can simply type localhost 3000. Everything is working fine. So here our application got started. You can come back here, go to the close this one, go to the pages, come here, and you can type ICO Marketplace. You will see this one. If you want to check that whether tags are working or not, you can do that very easily. H1, and you can paste here, and here we have that. Every single thing is working fine, and everything is looking good. Now we have to get our environment variable. So we can come back to .env local, and here we have to provide our Pinata API key and secret key, which allow us to deploy the images when the user will create their token to the IPFS. So this is the first thing we have to get, and we're going to provide the address of our contract once we'll write it and deploy it and do the testing. So let's get these two first. So come back to the browser, open a new tab and type Pinata Cloud. This is a really powerful platform which allow you to upload your images to the IPFS for absolutely free. So you can create your account for free and you can utilize their platform. So make sure to come and have a look. You can do a lot of things. You can build a complete hosting platform using this Pinata. So I already have my account, so I will simply log in. If you don't, make sure to create your account. So here I'm back in my Pinata dashboard, and here you can see all the files which I have uploaded using this Pinata IPFS. That's all reflecting here. Now you have to get your own API key. So click on this API key, and here you will find all the API key which you have created. So I have already created. Now I'm going to create one more time. So I'll click on this new key, and here you have to give the name. So I'll call it Marketplace, and I want to have a admin labeled accessibility. So I'll click on this admin, and from here I can set the limit that how many files I want to allow user to upload through this API. The maximum limit is 1000 in one API, so I can simply go with 1000. I'm using the free account. If you want to upgrade, you can simply upgrade and you can allow the user to upload unlimited files. So that's what we have. Now we can click on this generate API key, and it's going to generate the API key for us. And here it gives us three options to configure our keys. So first we can do in the front end by pasting API key and secret key, and the third option we have through the backend, which is JWT, but we're going to go with the front end through our environment variable. So simply copy this one and open up, and here you have to provide your key. So that's the first thing. Now we can come back here. We have to get this secret key, and that's what we can simply provide here. So that's the first set of requirement we have successfully fulfilled. We got our Pinata API key and secret key, and later we're going to provide our contract address. So we got it, and I'm going to simply come back here, done, and I'm going to simply close this one. So I'm going to delete this API key once I will complete the entire project. So I would suggest you to use your own API key, don't use my, because I'm showing you. Okay, so use your own API key because this will not work after the project is completed. Now we got our environment variable, simply close this down. Now we can start working on our project. So first we're going to work on our smart contract, then we're going to test that and deploy to the test network. After that, we're going to write the code for our context management, where we're going to write and interact with our contract. After that, we're going to work on the front end part. So that's how we're going to build this project. So I'm going to simply close this one and come back here, and let's start working on our ICO cell contract. Click here. So let's start writing our smart contract. So first we have to give the license identifier. So I'll say SPDX license identifier, and it's going to be MIT. So that's the general convention we have to follow when we want to write the smart contract. There is multiple license identifier, but I'm going with a specific one. Then we have to define our salty version. So pragma salty, and the version I'm going to take above 8. So this is how we can define. Arrow up 0.8.0. This is the salty version I'm using, and this one is the most stable, and most of the popular contract you will find which follow this particular salty version. So now we have to write the interface of our ERC20 token. So we have two ways to do that. We can do it in the front end, or we can do it within the contract. So the most secure way we have is to do it within the contract. So let's come here, let's define the interface, and it's going to be IERC20. And in that, we're going to have a couple of important functions. So what I'm going to do is, before we write these entire functionality, let's try to build out the entire layout, that what are the functions, what are the data stage, what are the struct we're going to have. After that, we're going to simply build that all the complete function. So that's the interface. Now we have to build the contract. I'm going to call it ICO Marketplace. And now we have to define the struct, because we're going to take the information about the token. So let's define that. So this will call struct token detail. In that, we have to define all the data about the struct. Now we can come back here, and now we have to simply define the modifier, because there are certain check we have to do. We have to do the check for the creator, because it's our ICO marketplace. So different user will come and create their ICO. So we have to validate that the user is trying to buy or withdraw the function, withdraw the token, they are the valid creator or not. So that's the check we have to do. And that's what I'm going to do with the help of modifier, but you can do within the function. So let's do with the modifier. This is the advanced approach, which you will find in most of the popular contract. So let's come here, And the first modifier we have to build is for the supported token, because we have to check whether the token is supported or not when the user will buy or withdraw. So in that, we're going to simply pass the address, which I will complete the function. So let's build the layout first. Now the second modifier we have to build is for the owner only. So there are certain functions we have to restrict with owner. Owner can only call and perform the transaction. Then we have to build the third modifier, which is going for the creator. So this modifier will help us to check whether the function caller is a creator or not. So these are the three modifiers we have. Now we have to take this receive, and we're not going to receive any fund in the contract. So I'll say external payable. So this is the entire layout we have. So this looks fine. And here we have the modifier and the receive. And now we have to work on our constructor and the functionality. So let's provide our constructor. And in this, we're going to simply update the on of the contract. So let's come back here. Let's try to build the function. So first, contract functions. So the very first function we're going to have is to create ICO. So let's call this create ICO cell. In that, we have to provide all of these details. So it's going to be have address of the token. Then it's going to have the price, that what is the price the user wants to set for an ICO. Inside that, we're going to build all the logic. So this is the first function we have to create. Now let's come back here. Let's create the second function, and this will call the multiply. And the reason why we are building this function, because we have to control the overflow and underflow error when we're going to perform the transaction. So that's why we want to use this multiplier, a math library. So in that, we have to pass two numbers, x and y, and it's going to return the z. So it will keep the track of underflow and overflow. So it's going to be an internal function, pure, and it's going to return the z, unt 256z. Very simple function we have. This is the multiplier function. Now we have to simply come here and let's try to build the function for buy token, in which we're going to use this multiplier function. So it's going to take a couple of arguments. It's going to take the address of the token, and it's going to take the amount of the token, that how many token the user wants to purchase, and it's going to be an external function payable. And here we have to use our modifier. So first we have to check whether the token the user wants to purchase is supported in our ICO contract or not. So we'll use this supported token, and in that we have to simply pass the address of the token. That's the first thing. So if we come back here we have this one. So that's the one check we have to do. Then we have to allow the user to buy. So that's the buy token. Now we can come back here. Let's write the next function, and this one is called get balance. This will return the balance of the token. So it's going to take the address, will pass the token address, and it's going to return the balance. So it's going to be external view return, and it's going to return the unt variable, which is the amount. Now we can come back here. Let's build the next function, and this will call get supported tokens, and this will return the array of all the supported token, so we can simply validate in our front end. So it's going to take no argument, and it will be external view return, and in this will return an array of address. So we'll say address array memory, and this is the variable which we're going to create in a while on top. So just wait. Now we can come back here. Let's build a next function. This will call withdraw, and it's going to take a couple of arguments. First, it's going to take the address and number of token the user wants to withdraw. So in that, we have to do a couple of check. So it's going to be external only creator. In that, we have to simply pass the address of the token, so it will automatically validate the user internally. That's the check we have to do. Then we have to check whether the token is supported or not. And in that, we have to build entire logic. So that looks good. Now we can come back here. Now we have to build the next function, which is called get token details, and this is going to return the details about the token, which we're going to utilize later to check the pricing and compare that whether the token is left in the contract for sale or not. So it's going to take the address of the token, and that's the only argument it will take, and it's going to be external view, and it's going to return the entire token. So we'll take this token details and memory. Very simple. Same approach we are following. Now once we're done with that, now let's write the next function, and this function will allow us to get tokens created by a user. So in that we have to simply pass the address of the user, and it's going to give all the token which a single user created as an ICO. So we'll take this address and we'll take this creator. It will be external view return, and it's going to return the entire struct as a form of array. So we'll take this tokens details as a memory. Got it? Now we have to build the last function which will return the entire token available in our ICO contract. So this one is for the single user, but we have to write a function to get all the ICOs of all the token. So let's write it down. So we'll take this function get all tokens, and it could be external view return, and it's going to return the token details array memory. And that's what the logic we're going to build inside this particular function. So this is the structure of our entire smart contract. I hope you guys have understood that what structure we are following. And now we're going to take one function, one feature at a time to understand properly that how we're going to build the logic for making our smart contract work. So this is our license identifier and solidity version. This is our interface for ERC20 token. This is our struct for token in which we're going to keep all the details. This is the for 3 modifiers and the receive function. Then we have our constructor, create, multiplier, buy, get balance, get supported, withdraw. All of this function we have built. Now we can start working on our interface first. In that we're going to have couple of function which you will find normally in ERC20 token. So let's come back here. Let's create the first function. We'll say function, and it will be a transfer. So when the transfer of the token will happen, we're going to use this interface to perform the transaction. So it's going to take, so first it's going to take the address of recipient, then it's going to take the amount is going to be external return, and it will return boolean value, so whether the transaction is successful or not. So that's the transfer function we have. Then we can build the next function. This will call balance of, it's going to check the balance of the user. So in that we have to pass the address of the account, external view, and it's going to return the UNT variable. Simple. Now we have to build a third function which allow us to get the symbol of a token. We can do it in the front end, but I just want to keep everything within the contract. So all we have to do is to simply provide the call this function, and it will be external view return, and it's going to return the symbol which is a string. So we'll say memory. Now we have to simply return the total supply as well, external view return, and it's going to return the UNT variable. Then we have to simply build the function for getting the name of the token. So we'll say name, external view return, and it's going to return string memory. So this is the entire interface for our ERC20 token, which give us the sensitive and important information about the token, so we can fill out in our struct entire interface. Now we can start working on our struct. So we can come here and we can define all the variables. So first is going to be the address of the token. Then we're going to take the boolean value. So it's going to say supported or not, because when the token will be added in the contract, we have to turn it to true, but by default it will be false. So supported. Then we'll take this UNT variable for the price. Then we have to take this address, which is for the creator. Then we have to take a string, the name, and we have to take the symbol. So these are the details we are taking of a single token. So let's format this. This looks good. So this is our entire struct, looks good. Now we can start working on our modifiers. So first we're going to start working on supported token. So I'm going to pause the video for a moment. I just want you to give a try that how we can simply validate the supported token. So I'm just pausing. 1, 2, 3. I hope you guys have done it. Now let's me write the function. So before we write the supported token functionality, let's try to take the mapping, in which we're going to simply map the entire data. So let's come back here. Let's call this mapping, and here we have to simply build a simple mapping. So we can take this mapping, and it's going to take the address, and it's going to return the entire details about that particular token. So we'll take this token details, we'll say public, and token details with a small t. I hope you guys are familiar with the mapping and the data structure we follow in the Solidity Smart Contract. If not, then I would suggest you that simply complete the entire project. After that, take this Solidity course. There is a huge playlist. Simply follow that. You will master Solidity programming language. Now we are done with the mapping. Now we have to take the address, and it's going to be an array type. So remember, here we are simply returning the entire address of all the tokens. So where it is, this is the function get supported token. So we are simply returning the entire array. So we'll take this array and we can call this public all supported tokens. Now we have to take the owner address. So we'll take this address public owner, which we have to update in our constructor. So the person will deploy the contract become the owner. So looks good. We are done with the entire data structure. Now we can come here and let's take couple of events, because whenever the transaction will take place, we have to initialize the event, and events are very important in smart contract. So let's take that. So I'll call it events. So we're going to take all together of events. So let's come here. We'll say event. Then we have to define the name of the event. So we'll take this token received, and then we have to pass the argument with the index value. So first is going to be the address index, and this will be called token. Then we have to pass the address of the from, and we have to pass the amount. So these are the argument we have to pass in our token received. I'm going to simply replicate this 3 times, and we're going to have 4 events. So let's change this to, this will call transferred, and this is going to be the same like token address from an amount, and this will be 2. And then we're going to come here and change this to withdraw. This will be same, and here we have to make it 2, and we'll have the amount, and the last one is going to be the added. So this is the address, and I'm going to simply remove this one because we're going to have multiple argument. So first thing is going to be the UNT, means the price. Then we're going to have the address of the one who's going to create and add the token, means the creator. Then we're going to have the name, and we're going to have the symbol of the token. So these are the details we have to pass in this event. Looks good. So these are the 4 events we have in our contract. So far things are good. We have no issue in our contract. Looks good. Now we can start working on our modifier. So this is the logic we're going to build. So simply open this one. In that we're going to simply receive the address of the token. So let's receive the address. And here we have to simply build the condition. We have to check the requirement. So we'll take this requirement and we have to build the statement. So we'll take this, build the statement. So we'll say that token details, which contain all the information about the token which will be added by the user, we'll have this in this particular variable. So we'll say in that, to get a specific token, we have to get the address. So we'll pass the address of the token. So in this way, we'll know that the user is trying to interact with this particular token, because every single address is different and unique. And here we have to call this supported feature we have, because this will be true. So if I come back here, if I take you here, you can see that here we have the supported. So when the user will add, it will turn it to true, and that's what we are matching up. So now we can come back here. It's true. If it's true, then continue with the function. Otherwise, we have to display the failed message. So let's display the error message. I'll say token not supported if the token don't exist in our function. If it exists, then we have to simply continue the function, and this is how we can do it. So this is our first supported token modifier we have. We are done with this. Now we can go with the only honor. So looks good. Let's create. So now we can go with the only honor. So come back here. In that we have to check for a condition. We'll take this message.sender is going to be honor. Otherwise we have to throw the error message that caller is not the honor. Simple. And we have to simply continue the function. So this is the only honor. Now we have to check for the only creator. In that we have to simply receive the address of the token, and we have to build a similar statement. So in this we have to first get the message.sender, and then we have to simply compare with the token. So we already have the token details. In that we can pass the token address, and then we can compare with the creator. We'll say creator. If it's not, then we have to throw the error message. But if it's true, then we have to simply continue the function ahead. And here I have to fix this typo. So it's address. So this is our only creator modifier. Looks good. So far things are good. We are matching up with this creator, and that's what we are comparing. So let's bring this space down here. Okay, now it's good. So we are done with all the modifier. Now we have to work on the receive function. So in this, we're not going to receive any fund. So I'll say revert, and we have to display the error message. So I can say contract does not accept Ether directly. Got it? So we got this receive. Now we can work on our constructor. It's pretty simple. So we have to simply update the address of the owner. So this is what we have to update. Now we can come back here, and we'll come back here in the owner, in the constructor, and say owner equal to message.sender. So we can simply update that. So we are done with this constructor. Now we have to start working on actual functionality of our contract, like create ICO cell. So far you guys have understood that what exactly we have developed and how our contract getting structured. Now we can start working on our create. So come back here. We are done with this event, we are done with this struct, we are done with this interface, and let me have a look one more time. Now we can start working on our function. So come here. First thing we have to do is we have whatever information we are getting about the token, like token and token price. So that token address we have to pass to our interface. So we can do that very easily. We can take our interface we have developed. So we have our interface. Now we can simply take this token interface, and we have to simply pass the token address. So in that way we can able to make the reference between the token and all the data, all the function we have defined with the token. So we got our interface, all of the interface function. Now we can come back here. Once we get that, now we can simply come here. We have to first get the name and the symbol of the token. So we'll say string memory, we'll say token name, and we have the token dot name. In that way we can get the address. In that way we can get the name of the token. Then we have to get the symbol of the token. We'll say memory token symbol function. So we got the token symbol, token name. Now we can come back here. We'll take this token details, and we have to create the reference to the current token, and all we have to do is to simply update our struct. So we can do that very easily. We'll take this token details, and it's going to be an object, and simply update all of this data. So you can come back here. First is going to be the token name. Make sure the order is very important, and the spelling which you have given in the struct, we have to give the exact one. So this will be the token address. Then we have to define this supported is going to be true. Then we have to take this price is going to be the price of your user. So this price. Now we have to define the creator. So we have this data message.sender means the one who is calling the function. We're going to take their address. Then we're going to take the name. So we already have the token name, and we have to define the token symbol. Token symbol. So that's all we are updating in our struct. Looks good. Now we can come back here, and we have to simply push the address of the token to our address array. So we'll take this all supported token push, and we can simply pass the address of the token, and we have to initialize our add token event. So we already have that event, and we have to provide all of these details. So first is going to be, then we have to define the price which users will provide. Then we have to provide this message.sender means the one who is calling the function, and then the name of the token. We'll take this token name and token symbol. Got it. And this looks good, and I have to provide this space here. So it's space, and I have noticed one thing. So I can simply come back in my event. Okay, I'm getting some sort of warning. So I can come back here in my event, and I can see there is a problem in our name in add token. So it's only 1A. So let's remove this. This looks fine. Simply remove this 1A. Remove 1A, and that looks good. Now our event is look good. Now we can come back here, and I can see I'm still getting this red line, and I know why it's happening, because we have to fix this small problem. So here we have to call this external, or you can call it public. So I'll call it external function. So anybody can call this particular function, and they can create their ICO in our smart contract. So looks good, pretty good. So we're getting this data, we are getting the interface connection, we're getting the name and the symbol, and that's what we are updating in our struct. And at the end, we are simply initializing our event. So this is the complete function which will create the ICO of a token. Now we have to work on the next function. So this one is multiply, and it's going to be a very simple function. It's a one-line function we have to write. So in that we have to check the required condition. So we'll check this required, and in that we have to build the condition. We'll take this y equal to 0 or z equal to x multiplied by y, then we have to simply divide it by y equal to x, and it will take care of the underflow and overflow. So you can check the math library. There we have multiple method. Here we are going with the multiplication, but if you are doing any plus minus, you can take those function and you can embed in the contract. But we are simply dealing with the multiplication because we have to calculate the price with the number of token which user wants to purchase. So that's why I'm going with this multiplication. So we are done with this multiply. Now we have to work on our buy token function. So it's going to take two data, address and the amount, where we're going to use our multiply function. So token supported, that's what we are checking. And if I come back here we have this one. It will automatically check and throw the error message if the token is not supported. So now let's open this function, and first thing we have to do a little bit check. So we have to build a condition. We'll take this amount should be greater than 0. So first we have to check that the amount, the number user is providing is not 0. They have to buy at least some token. They cannot buy 0. So that's the check we are doing. So we have to throw the error message that amount must be greater than 0. So that's the first check. Now we can come back here and we're going to take our token details. Memory, we'll say details, which is going to be the token, and we have to simply create the reference. So we already have this token details, the mapping in which we have all the details. So we're going to simply pass the token address. So that's how we can get that specific token which user wants to purchase. Once we have that token, we can simply, so it's going to be a UNT variable. Then we have to say total cost the user will pay, and we can use this multiplier function we have. In that we have to simply pass the two things, x and y. So we have to pass the token price, detail dot price, and we have to pass the amount which user wants to purchase, the number of token he wants to purchase. And this is the only thing. We got the total cost. Once we have the total cost, we have to check for a condition. So we have to say method dot sender value, means the value he will send, it should be equal to the total cost. Otherwise we have to throw the error message because we need to have the exact amount send. And we can come here. Now we can simply do the transfer of the token from the contract to the user who purchasing this particular token. So we can do that very easily. We'll take this boolean and we'll say send, and we have multiple method to call, but I'm going to use this particular mode. So we'll say detail dot creator dot call. Then we're going to simply pass the value, and the value we have is the message dot value the user is passing in the function, and then we have to call the function. So this will do the transfer, and it's going to return either true or false. True means the transaction is successful, false means the transaction failed. So we can take this required, we'll say send. If it's true, it will continue ahead, but if it's false, then it's going to throw this error message. We'll say fail to transfer ether to token creator. So once the fund transfer successfully, after that we can come back here and we can simply transfer the token back to the user. So first we are transferring the fund from creator to the owner of the token, and now we have to do the transfer of the token. So we'll take this ERC22 interface, we'll take this token ERC24, we have our interface, in that we can pass our token, and then we can simply call the transfer function. So we'll take this token transfer, in that we can pass the address and the amount. So we'll pass this, come back here, and here you can see here we have this transfer function, and that's what we are calling. In that we have to pass two things, the recipient and the amount. So we can come back here, we can pass the recipient. So recipient is going to be the message dot sender, the one who is calling the function, and we have to pass the amount and just remove, and we have to simply multiply with this 18 because the transaction will take place in way. So we have to simply take that into care. So we'll say 10 multiply by 18 and remove this extra comma, and we can simply display our error message if transaction fail. Transfer failed. After that we have to simply initialize our event. We'll say this transfer token transfer, and that we have to pass the token address where we have sent the token and the amount. And that's our buy token function. Pretty simple, but very powerful. Okay, first we are checking the fund, then we are getting the relation and the cost of the token, then we are transferring the ether back to the creator, and then we are transferring the token to the buyer. So this is our buy token function. Now we can start working on our get balance. It's going to be a very simple function. All we have to do is to simply pass the token address. So open this function. Now we can take this require statement, we'll take this token details, and that we can pass the token address, and we can get the access of the supported, and we'll say token not supported. So first we have to check whether the token is supported or not, then we have to simply send the price. So we'll take this interface address, then we can have the access of the price of that particular token. So we'll take token balance of, and we can pass the, and we can call this because this time we have to check the balance, that how much token is available in our ICO contract. So that's how we are checking. So this will return the balance, that how many tokens are left in our ICO contract for a specific token. So this is the get balance function. Now we have to get this get supported token. I'm going to pause it for 3 seconds and I want you to give a try. It's going to be a very simple. I hope you have tried. Now let's write the function. So what I will do, I have to return this entire array and all of this data we have into this particular array. So that's what I have to do. It's pretty simple. So I can come back here. I'll take this return all supported token, and that's it. Simple. It will return all the array in our front end when we'll call the function. Now we have to write the next function, which is the withdraw token. That's what we have to write. Now we are receiving two arguments, token address and the amount, and this function can only call by the owner of the token. Let's call this token and let's build the logic. Creator and token. So we'll take this require statement, amount greater than 0, because if there is no token available, then we don't want to make the transaction. So we have to throw the error message. Amount must be greater than 0. After that, we have to build the relation with the interface. So we'll take this IRC20 and address. Once we got that token, now we have to simply take the, now we have to check the balance of the token. So we'll take this balance, token dot balance of, and we have to pass the contract address. So we'll take this address, this, so we can have the balance, that how many tokens is available in the contract. Once we check that, then we have to make the transfer. So we can come here, we'll take this token transfer, we have to pass the recipient address, message dot sender, and the amount, and we have to throw the error message if anything goes wrong. But before we make the transaction, now we have to initialize our event. So token withdraw, and we have to pass these 3 arguments, token address, to message dot sender, and the amount. And we have to do one thing. You can see the balance, we have to check for a condition. So that's balance is there. We have to, let's build another required statement. So let's come here, we'll take this required, and we'll say that balance should be, if the balance is greater or equal to the amount, then we want to continue, otherwise we have to throw the error message. Insufficient, we can call it token balance, and that's the entire function for withdrawing the token. That looks good. I hope you guys have understood that what exactly we are doing. We are checking for a creator, then supported, then we are checking the amount, then we are building the relation between the token with the interface, then we are checking the balance of the token in the ICO contract. After that, we are making the transaction and initializing the event. So looks good. That's the entire. Now we have to write this token detail function, which will take address of the token and is going to return the details, the entire struct of that particular token. So that's a very simple one. So I can come here. First, we have to check whether the token is supported or not. So you can do it by writing inline statement, or you can do it with a modifier. I'm using both the one to show you that there is multiple ways which you can use to write your smart contract. So if it's true, then we have to continue, otherwise we have to throw the error message. Now we have to simply return the entire information, entire struct of that particular token. So we already have this token details. In that, we have to simply pass the token address, and it's going to return the entire information about the token. Got it? Now we have to write the last two function, get token created by and get all token. So let's start with the get token created by. In that we have to simply pass the address of the creator, and it's going to return an array. So let's come here. So first we have to find the length, that how many tokens created by a particular user. So we're going to take a UNT variable, and by default I'll say count is going to be 0, and we have to run a two for loop. In the first loop we have to calculate the length. In the second loop we have to return the entire token. So let's come here, we'll take a for, we'll say UNT I equal to 0, we have to increment, and we already have this all supported token which have all the addresses of the token, and we have to simply get the length. So in this way we can have the length, that how many tokens are created so far, and we have to increment. Inside that we have to build the logic. So we'll say if token details, in that we can simply pass the all supported token, and we'll match with the every single address, and we can say if it's equal to creator, then we have to simply increment the count plus plus. Simple logic. What we are doing, we are taking this particular variable, we are running this for loop, we have the entire address of all the token, we are checking for the length, then we are running the loop. In this we are trying to find out that if the address of the creator is matches with the address which we provide in this, then it will simply increment the counts. Once we're done with that, now we can simply come here and build the second loop. So before we do that, we have to make the length of an array which we're going to return. So we'll take this token detail, and will be a memory token, and we'll take this new token details, and in that we have to simply pass the length which we have in the count variable. It's going to return a new array. Then we can take a UNT variable and we'll say index 0. Now we have to simply build the if statement. So we can simply copy this one, and that's going to be a similar one. The changes we have to do right up here in this count variable. So this looks good. We have to still match with the creator and the token creator and the one who's calling the function. So here we can simply come, we can take this token, and let's call this tokens S, because it's going to be an array. So we'll have this tokens index, and we have to simply take this token details all token index, and we have to increment the index, or at the end we have to simply return the tokens. Very simple. It will return all the array of that particular user address we're going to pass in the function. So that's the complete function of getting token created by user. Close this one. Now we have to write the last function, get all token, and it's going to be a quite similar to the other one which we have written for a single user. I just wanted to give a try. It's very simple. I hope you have tried. Now let's write it down, the next function. So what I will do, we have to return the array and all the token from our ICO contract. So we'll take a variable, and it's going to give us the length. So we already have the length which we can access through all supported token dot length. Okay, we got the length. Now we can come back here, we'll take this token details, and we have to build a new array which we have to return. We'll call it tokens. Let's call this token details length, and I have to check the length spelling. So this one is copy paste and copy, and here. So this is simple, same logic. Now we can come back here and we have to run the for loop. So what I can do is I can simply take this UNT variable I equal to, then we'll take this if I is less than length, then I have to simply increment. In that I can simply take this tokens, and we can simply return the token all, and at the end we have to simply return the tokens. So in this way we can able to return all the tokens as an array from this function. Pretty simple. And that's the entire smart contract for our ICO marketplace. So we have taken this license identifier and pragma sorority version. This is the interface. This is our struct. We have the datas, mapping, address and honor. We have the event. We have the first modifier. We have the second modifier only honor, and the third modifier only creator. Then we have this receive. We have the constructor, and here we have the very first function for creating ICO. Let's close this up. We are getting all of these details. Then we are making the relation with the interface. Then we are updating the data into a struct, and at the end we are initializing the struct. So simply close this one. Then we have this multiplier which keep the track of overflow, underflow. When we do the mathematical operation within our contract for calculating the price, then we have the buy, we are checking for the condition, and then we are making the transaction. Then we have the get balance of a specific token. Then we have this get supported token, and here we have the withdrawal function. Then we have this get token details. This is the get token created by, and that's all we have. And this is the last one, and I can see there is a problem in this spelling mistake. Okay, I know it's a capital T. Change this to capital T, it will fix the issue. Token details, and that will fix the issue, because that's what we have called here. And that's the entire smart contract we have written. So everything looks good, we have no issue, everything is compiled successfully. You can see I'm not getting any warning, but we're going to do the testing. Just wait. So come back here, and now we're going to start working on our ICO ERC20 token. So this is the optional contract I'm going to create for ERC20 token, and I hope you guys already know how to do it, but anyway I'm creating it. In this I'm going to use Open Zeppelin library to create it. So let's come back here. First we have to define the SPSD license identifier, and I'm going to use the same version MIT. Then we have to define the Pragma Solidity version, so it's going to be the same version. Then I have to import the Open Zeppelin library because we're going to use it for creating our token, or you can create your custom token. It's totally up to you, but I'm going to use this Open Zeppelin library. So let's call it import, and this is the general path because we're going to deploy our contract through Remix ID. So when you will copy and paste the exact code, it's going to take this general path. So let's provide the path @Open Zeppelin. Then we have to go into the contracts. Inside the contract we have the tokens. In that token we have the ERC20, and from there we have to access the ERC20 contract .sol. So that's how we can access the Open Zeppelin contract. Now we can come back here. Let's build our contract. So we'll take this contract, and I'm going to call ERC20 token, and we have to have the feature. So we'll take this ERC20 contract access, and that we can simply build our constructor. So we'll take this constructor. In that we're not going to provide any argument. So let's initialize our ERC20 interface. In that we have to pass the token name and the symbol. So let's call this token, what I can call it, let's call the blockchain coder, and for the symbol I can call it TBC. You can give your token name. That's what we got it. Inside that I have to initialize the supply. So we're going to use this mint function called mint, and in that we have to initialize the supply. So I'll take this message.sender is the owner, means the one who will deploy the contract is going to be the owner, and this much supply I want to initialize. So I'll take this close to 50,000, and it's going to be in the way, so I will say 18, and that's the entire contract for our ERC20 token. Very simple but very powerful. I hope you guys have understood that what exactly we have done. Now close this one. Now we have completed our entire smart contract. So open your ICO contract, and this is what we have coded. So I'm going to simply use Remix ID for deployment. So simply copy the entire smart contract from here. Open up your browser, then open a new tab and open Remix ID. And here we have on the Remix ID, and here you can see that I have all the folder and files. So I click on this contract, and there is only one file I have created. So I'll select this one, and I'm going to select all the code, and I'm going to remove because this is the old code, and I'm going to simply paste the code we have coded. Click OK. So you can see our contract got compiled successfully. There is no issue we have in the contract. Now we have to deploy the contract to Polygon test network. So before we deploy, you have to make sure that you have added the Polygon test network in your MetaMask. So what you have to do is simply click here, and you have to click, and from here you can pick multiple provider. You can test locally, but I'm going to use this MetaMask injected provider. I have Phantom Wallet, but I'm going with the MetaMask. Click on this MetaMask, and it's going to pick. So first thing I have to do is to simply open up my MetaMask, and from here I'm already connected with the MetaMask, and you can see it's fetching the information. So we have connected with MetaMask successfully. You can see the balance which is reflecting here, the chain ID. So I'm connected with the Polygon MOI network, Polygon MOI. In case if you don't have it, Polygon MOI, so you can add it manually. You can click here, and it will take you to the MetaMask page. You can click on this add network manually, and here you have to provide all the details. MOI, I have to provide the RPC URL, so I'll say POLYGON Polygon MOI MetaMask. Type this, you will get the very first link. Click on that, and there you will find all the details. So this is the exact thing you have to provide. So simply get the RPC URL, copy and paste here. Then you have to get the chain ID. So this is the chain ID we have, and paste here. Then we have to come back here, get the symbol and paste here. Then we have to get the explorer, simply copy, and that's what you have to paste here. Once you provide all of this information, click on this save, and the network is added successfully, and you can click on this switch Polygon MOI, and you are back to where we have left and deleted the network. So everything's look good. Now we can come back to the remix ID, and you can see I already have this much fund available in my wallet, in my Polygon MOI network. If you don't have fund, then you have to get it, then you can able to deploy the contract. So to get the faucet, you can come back here, type Polygon faucet, click on the very first link, and there you can able to claim free faucet, like you can able to get 0.2 faucet. So first you have to join the Discord server. So click on this connect with Discord, and first you have to authorize, then you have to join. I have already joined the Discord, so it's going to ask me for authorization only. Once I do the authorization, I have to simply click here and change the network to POS, and I have to paste the address. So I have to get the address of my wallet. So I'll simply copy this one, and I'm paste here and click on this submit, and it's going to make the transaction and send this much fund to my address. So click on confirm. This process might fail because yesterday or today in the morning I have done the transaction, but let's see. Finally I got the transaction went through, and you can see I got the fund. It will go up. So just wait, it takes a little bit time, or sometime it's required page reload. So you can simply close this one because we have done the successful transaction. You can also close this one. You can also close the MetaMask. You can also close this Explorer. Now we can come back to the remix ID. Click here, and you can see this fund went up to 3. So we have successfully received the faucet. Now we are ready to deploy our contract. So our contract got compiled successfully. Make sure you are connected with the injected provider MetaMask, and make sure you have to pick the exact account which you want to use for deployment, because that particular account becomes the owner of the contract. Okay, now we can come back here, and here you will click and you will find these 2 contracts. So we have to deploy this ICO Marketplace, this particular contract, not the interface. So we can click here and we can click on this deploy. So let me bring it up and click on deploy. Once you click on deploy, it's going to make a call to our smart contract, and we have to confirm the transaction. So let's click on confirm, and the transaction is happening. You can open this one and you can see the contract deployment got failed. So let's see what exactly went wrong. And here we got the problem with the gas price. You may want to increase the gas limit. So we have some issue with the gas limits. We can easily able to fix that. So here you can see that's what we have. We can add the custom gas limits. So I can simply go with this, let's say 8. And now we can simply try to make a transaction. Click on this deploy, and it's going to make a call. And here it's making a call to our smart contract. And now we have to simply confirm. And this time the transaction will succeed. So it's failing again. So I have to check what exactly went wrong. So let me do one thing. I guess I have less fund in this, and this fund is not enough to complete the transaction. So let me switch back to my next account. This is the account number 2, in which I have quite same fund I have. This fund has also the same fund, and this one is also the same. So let's try with this one. So let's click on this deploy, and it's going to make a call. And here I have to say confirm, and the transaction is failed one more time. So let me clear my MetaMask history. Maybe there is some problem. Clear it up. So we have cleared the MetaMask history. Make sure to reload the page. Come back to the contract, and everything's look good. I can come back here, click on this, pick this injected provider, and it's going to pick the account, and the balance is reflecting. I can select the same network, open it up, click on deploy, and it's going to make a call. Just wait. Let's click on this confirm, and here the transaction is happening. And this problem happens sometime we open the Remix ID browser for a long time and not reload it. That's why it's caused the issue. You can see the transaction went through with the same gas amount, so there is no problem in the code. And here we got the address of our contract and the interface. So if we want to interact with our contract, we can do it right here. We can able to make all the calls and create and token and buy token. That's all we can do right from here, but we need only our address. So simply copy this one, and I have used the account number 1, and you can see it went down because we have views for deploying our contract. Now we can come back to our code. We can go to our .env file, and all I have to do is to simply paste the address, and this is our newly deployed contract address. So that's the first thing. Once you're done with that, now you have to close this one, and now we have to get the ABI of our contract. So to get it, you can click here. You can go to the artifact. Inside the artifact, you have this ICO Marketplace JSON. Click here and simply copy, come back, and that's what you have to simply paste here and paste it. And that's the only thing you have to do. Once you do that, simply close this one. So we got our ABI, we got our contract, everything is looking absolutely fine. We have no issue in that. So we got it, everything looks fine. So we got our addresses, we got the API keys. Now we have to start with our context management.